All right, let's solve a mystery. A really weird engineering mystery that might just be hiding inside the phone you're holding right now. We're going to dive into why some iPhones get stuck restarting themselves. And it all boils down to one simple number.
180. That's the number, remember it. We're talking 180 seconds, which is, of course, exactly 3 minutes. So, what makes this number so special? And why on earth is it secretly programmed into your iPhone?
Because that's really the heart of the question, isn't it? Why would your iPhone just decide to restart itself every 3 minutes on the dot? It feels like a bug, but it's way too precise, way too consistent to be just a random glitch. Today, we're going to find out why it's not a bug at all.
Okay, let's dive in. And every good mystery starts at the scene of the crime, the phone itself, and this bizarre, perfectly timed restart that has been driving people crazy for years.
So picture this. Your phone seems to be working perfectly fine. You're scrolling, maybe texting a friend, and then, bam, right at that 180-second mark, the screen just goes black. You see the Apple logo pop up, it reboots, and then the whole cycle starts all over again. It's a super frustrating loop, but that consistency, that's our first big clue.
So where do you even start to look for clues? Well, lucky for us, the phone actually keeps a record of its own failures. We just need to know how to find its secret black box.
And that black box? It's called a panic full log. Anytime your iPhone has a major hardware meltdown, the very core of its operating system, what engineers call the kernel, spits out one of these reports. It's basically a snapshot of everything that was happening in the split second before the crash, just like in an airplane.
And here's the cool part. You can actually find this on your own phone. Go ahead and pause here if you want, follow these steps, and see if your device has any of these logs saved. This is where our digital detective work really begins, by looking at the evidence the phone leaves behind.
Okay, so if you did open one of those logs, you probably noticed it's not exactly written in plain English. It's full of these cryptic codes. And believe it or not, these codes have a pretty interesting history of their own.
See, before the iPhone 13, things were way simpler. The codes were these text-based legacy strings that a technician could look at and pretty much immediately understand. But now, Apple switched to these super complex, layered hexadecimal codes with the newer models, which has turned diagnostics into a serious puzzle.
Just look at this table to see what I mean. It shows the change perfectly. A problem with the charging port used to be a simple, readable code. Now, on a newer iPhone, it's logged as 0x800. It's like learning a whole new language.
And believe me, it gets even more complicated. These new codes, they can be stacked on top of each other. So let's say both the proximity sensor and the charging port are failing. The system doesn't give you two different error messages. Nope, it just adds the codes together and gives you one new combined code, 0x1800. A repair tech literally has to do math to reverse engineer what's gone wrong.
And this brings us to a really, really important point. This quote here says it all. The panic log doesn't just say, hey, this part is broken. It says that the main system has lost communication with a sensor. Now, sure, that could mean the part is faulty, but it can also mean a cable is loose, or even that someone used the wrong tiny screw during a previous repair.
Okay, so after all that digital detective work, we're finally at the big reveal, the huge plot twist. That incredibly annoying 3-minute restart loop, guess what? It's not an accident. It was put there on purpose. It's a feature.
So, who's the culprit? Meet the thermal monitor. You can think of it like a dedicated security guard inside your phone, and its only job is to constantly run around and check in with dozens of tiny temperature sensors to make sure nothing, absolutely nothing, is getting too hot. So here's the chain of events, step by step. First, one of those critical temperature sensors fails. It just goes silent. Then, the thermal monitor realizes it's not getting a signal anymore. That's when this watchdog timer kicks in and starts a very strict 180-second countdown. And if that sensor doesn't report back in time, the system assumes the absolute worst-case scenario, a potential thermal runaway that could lead to a fire. So to prevent that, it triggers a kernel panic and forces a hard restart. And that's it. That's the answer. The 3-minute restart isn't some random bug trying to ruin your day. It's a highly sophisticated failsafe. The phone's core programming makes a choice. It's better to be a useless, restarting brick than to risk a catastrophic failure in your hand or in your pocket.
So, mystery solved, right? Well, yes and no, because solving this technical mystery opens up a whole new can of worms, a much bigger and honestly more heated debate about who really owns the technology we buy.
You really have two completely different ways of looking at this.
On one side, you've got consumers and independent repair shops. They see this as an engineering firewall. They're saying, hey, how is it fair that one tiny, cheap sensor can basically destroy a $1,000 phone? It feels like it forces you back to the manufacturer. But then you have the engineers. From their point of view, this is the ultimate safety protocol. They see these phones for what they are, miniature reactors, just packed with an incredible amount of power. And for them, losing a temperature sensor is a massive, unacceptable risk.
And make no mistake, the dangers are very real. Some of these panic codes are basically a death sentence for a device. An Apple hot log, that means there's a serious short circuit on the motherboard that just can't be fixed. SAPA panic is even scarier. It means the secured chip protecting your most sensitive data has failed. And for your own security, all that information is now locked away permanently.
But here's a fascinating side effect of all this complexity. It's forced the independent repair world to evolve in incredible ways. To fix these phones now, you can't just be a person who swaps out parts. You have to be a digital detective who can read hexadecimal, a microsoldering artist performing surgery on a scale you can barely see, a real code breaker.
And all of this leaves us with one final and I think really important question to chew on. As our devices get more and more powerful and packed into smaller and smaller spaces, are we moving toward a future where they're just completely unrepairable black boxes? A future where we've traded our right to repair for absolute safety? What do you think is the right balance?